Good evening. My name is Ashwini Nair and I am here to present my project presentation for course EEL 6825, and my project is titled Context Awareness AI System. First of all, I would like to give a brief introduction to pattern recognition. Pattern recognition is one of the fields of machine learning. Machine learning can be distinguished into two types of learning, which are namely supervised and unsupervised learning. Supervised learning consists of training of the system via collection of labeled and synthetic data, whereas unsupervised learning often adopts a predictive and probabilistic approach towards classification. Now, some of the applications for my project. Mostly my project has revolved around the basics of natural language processing, but it has been important to develop intelligent dialogue agents and some of the other applications, as you can see here. Some of the existing paradigms of my project involved multiple variants of neural network structures. This included recurrent neural networks. Recurrent neural networks are a variant of artificial neural networks which can influence themselves with implementation of mathematical recurrences, which produce different network internal states. Generally, these recurrences involve functions of successive computed outputs. RNNs have relatively higher capabilities than multilayer perceptron neural networks and are only analogous to them once the recurrent weights are set to null. There are different types of recurrent neural networks, which includes Jordan networks, Elman networks, and memory networks, long short-term memory networks, LSTMs, which have also been used in my project. LSTMs can be defined as a network which has the ability to recognize context-sensitive languages. They have had a wide range of applications in language translation, modeling, text-to-speech synthesis. It consists of augmentation of logical gates called recurring gates and prevents gradient descent or backpropagation errors, which is also known as vanishing gradient. It can handle input signals with high bandwidths and requires long-term memories of tasks executed long time ago. Now I would like to talk about memory networks. Memory networks comprise of memories structured by arrays of objects which are indexed. They are also a variant of controlled neural networks, drawing inferences from their memories and are incapable of recognizing non-linear connections. In most of the evaluations, it has been found out that memory networks have outmoded the other existing network architectures. I would like to now briefly talk about n-gram classifiers. N-gram classifiers is specific to an order of n-1 hidden Markov model, which was discussed in class. Its concept has been inferenced by Claude Shannon's information theory, and their significant attributes are their elementary and scalable architectures, which contribute to realizing larger problem statements. They differ from RNNs since their functional dependencies lies only within past inputs. Convolutional neural networks. Convolutional neural networks is a type of feed-forward backpropagation neural network in which connectivity between its neurons has been inspired by the organization of animal visual cortex. The response of an individual neuron through stimuli within its receptive field can be approximated mathematically by a convolution operation. It's a variant of multilayer perceptron, which uses minimal amount of pre-processing. Another architecture which is newly introduced with this project was key-value memory networks. It has been found out that in one of the modules of my project, this architecture has provided optimal performance when benchmarked against the reference optimal solution, including human user. Now, these are some of the data sets which have been used for training my learning models implemented in all 8 modules of my project. My project, I intended to propose a framework consisting of implementing a series of synthetic tasks that can contribute to building towards an intelligent textual awareness system through implementation of innovatively designed learning algorithms. This involved challenging the underlying framework for multiple variants of logical structure of text specific to my training data. Also, I used synthetic data sets because it alleviated the problem defined as constraints through local optima, which researchers generally encounter in deep learning and were ill equipped to overcome from. We categorize a variety of questions into disjoint multiple feature sets which evolve dynamically as tasks and the network model progresses. That was my approach logic, which I wanted to mention. Now, moving on to the first task, the query answer task. I had 1,000 questions to carry out both testing and training, and also implemented a highly optimized structure if the enumeration for training is reduced. The format definition for every file involved in training consisted of a unique identifier assignment, a query, its specific answer, and the supporting fact stored or remembered to substantiate my answer. The last aspect always referenced within the synthetic data set created while training, whereas the identifiers begin with value 1. Shuffle permutations of similar sentences initially used for training were reused with a greater number, and it consisted of a set of 20 reasoning variations. Moving on to the next module, which was the conversation task. Conversation task was executed to holistically cover the complement space of the preceding stage or module. An exceptional function called silence was used to fill in blanks for end-user discrepancies. The purpose of my task was to deterministically evaluate synthetic model responses for conversing with a human user, and it included 1,000 dialogues for quality estimation, training, and processing. My responses included sentences and API calls, and my design of query consisted of 6 actions in total. Query structure was represented as an identifier, a user utterance, and a bot utterance. My next task would be the book for youngsters dataset. This aspect was covered to improve the versatility of my linguistic comprehension of learning model. Multiple books were used to increase the robustness of the learning models to interpret a missing aspect of training sets. For example, if I use 14 sentences of a story which has already been trained by my network model, if I input 14 sentences and if I introduce a discrepancy in the 15th sentence, my learning model will be able to determine the error. Also, I had refined the accuracy of my model further by encapsulating my training data into 4 classes, which were names, prepositions, nouns, and verbs. My evaluations were benchmarked against a convoluted network's QA structure, and my attention was focused more towards precise memory storages and towards infrequent semantic structures with respect to their syntactic counterparts. As you can see here, LSTMs provide exceptional performance for this class, and contextual LSTMs provide impressive performances for this class. Moving on to the movie dialogue task. The movie dialogue task was to carry out both formal and informal conversations revolving around cinema and motion pictures. The file formats align themselves to its predecessors. Initial efforts included recorded documentations of conversations among people to be used for training the system, but were unsuccessful. Subsequently, the synthetic environment approach, as introduced before, was more efficient, which included over 80,000 movies and 3 million instances. This phase includes authentic equipping of our model with a vast knowledge base spanning hard facts and websites like Twitter, Reddit, and to enable it to make astute movie recommendations. As you can see here, I trained my network model for a Reddit dataset as well. Moving on to the Wiki Movies data bank. This aspect of my model was capable of interaction of factual based reasoning with the human user and with inputs from the website, since the most common tool adopted to extract conventional information relevant to any field or discipline. It eliminated the conventional knowledge base's limitations, which is called KB, since it was sparse and haphazardly organized. A key value memory network, a network architecture which has been introduced newly, was implemented in this model, and it transformed and provided effective back propagation of error through stochastic gradient descent. It reduced the response time significantly, due to which the MAP and MRR values for this architecture are very high. Moving on to the next task, which was called the comprehension training task. This aspect of training efficiently simulated the development of a student's reasoning and knowledge base through learning and deductive reasoning from a teacher's perspective of imparting knowledge to the student. It effectively accomplished my goal towards building an AI capable of dialogue formulation, and it implemented a look-ahead approach to deterministically predict the tutor's responses to queries with an incentive-free approach. Moving on to my next module, which is called the generic query dataset. This dataset covered response generation to naturally constructed queries and constituted around 110,000 questions in collaboration with existing paradigms, disintegrated into multiple entities, namely nouns, names, objects, and establishing a flow relationship interconnecting them. A query sequence was formed with the help of a pseudo-random generator with a distribution of 70, 10, and 20% of training, validation, and evaluation. A simple pre-processing of free base was also conducted to scale up my performance, and this module was typically trained for three datasets, which were namely web questions, WQ, simple questions, SIQ, and reverb, which is known as paraphrases or PRP. Moving on to the next task, which was the automated dialogue task. My learning model was able to improve its performance through collaborative feedback from its online dialogue partner and which was actively interacting with the person. The datasets implemented for training are like the ones used previously and comprised of static level data, which were implemented through a reinforced learning configuration. It also reflected leveraging of feedback through extrapolation, balancing, and research. Some of the equations involved in this module are enlisted and mentioned in my project report. Now I will show the project demonstration and then I'll conclude my project.